Hello, I've had a question in Unit 3, Lesson 9, product rule. I'm looking at question number 5. We want to find the equation of the tangent line to the curve y equals that mass at the point 1, 5. So we need to find m, and the only way we can find m is by taking the derivative of the given function. So you're welcome to go ahead and use distributive law here and avoid product rule, but I think in the end it's probably going to be just as quick. So taking the derivative here, y prime, in the first bracket, derivative of 2 is 0. The derivative of the square root of x, I'll just put that up here. Square root of x is x to the 1/2, so it's going to be negative 1/2 x to the negative 1/2 multiplied by the original function plus first function untouched. The second one, the derivative of 1 is 0. The derivative of root x is 1/2 x to the negative 1/2, and the derivative of 3x is 3. So we need to do a little bit of simplification here and use some distributive law. So in the first one here, I'm going to do a couple of steps. So this is really negative 1 over 2 root x. That's what that becomes, because the negative exponent moves the x to the denominator. It's an exponent of 1/2, so it's root x. 1 plus root x plus 3x plus 2 minus root x. And then the second one, we have a similar thing happening here. 1 over 2 root x plus 3. So now you need to make a decision. Do you need to simplify any further algebraically? For most of us, this is the point we're going to plug 1 in because I'm looking for a specific value. So therefore, we're going to let x equal 1, which will tell me the slope here. So negative 1 over 2 root 1, 1 plus root 1 plus 3 times 1, plus 2 minus root 1, 1 over 2 root 1 plus 3. So I'm doing this in probably more steps than most of you will take, but I just want to make sure you see all the steps. So that simplifies to negative 1/2. Inside we have 1 plus 1 plus 3. So that gives me a 5 plus. Over here, 2 take away 1 is 1. And here I have 1 over, this will be 1 over 2, so a 1/2 plus 3. So a 1/2 plus 3.5, or 7/2. All right, so taking it the distance now, simplifying, so I have negative 5/2 plus 7/2. We end up with 2 over 2, or 1, so fairly anticlimactic. So now I can go to my equation, y equals m, x minus x1 plus y1, and substitute in my information. Slope is 1, and the point was 1, 5. So there it is in standard form. If you want to solve it down to y equals mx plus b, you end up with x plus 4. So assuming I made no errors, that is the correct process in determining the equation of the tangent line at the point 1, 5 for that function right there. If you have any questions or need further clarification, let me know, and I'll see if I can help you out.